Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we're going to solve logarithmic equations. So we're going to solve by using the inverse property b to the log base b of x is x. Now it's going to be very important for us to check our solutions here because the domain of the log function is restricted to 0 to infinity. So we can't take the log of a negative number. So once we get our solution, we need to check it by putting it into the original equation to see if that's going to make us take the log of a negative number. If it does, then that's not a solution. But if we put it in there and it's going to make us take the log of a positive number, then we're okay. So let's look at log base 5 of x minus 7 equals 2. And let's apply 5, the base of 5 to both sides. So we have 5 to the log base 5 of x minus 7 equals 5 squared. So if you remember the property, 5 to the log base 5 of whatever that argument is that argument of x minus 7. So we have x minus 7 equals 25. Or when we add 7 to both sides, x equals 32. Now, does this solution check? Well, if I go back to my original equation up here and I put 32, 32 minus 7 is a positive number, so I'm taking the log of a positive number. So yes, that solution checks. Let's look at another one. We have log base 2 of x plus 50 equals 5. So let's apply 2 to both sides. Log base 2 to the log base 2 of x plus 50 equals 2 to the 5th. So all this cancels and we're left with x plus 50 equals 2 to the 5th is 32. So if we go through and subtract 50 from both sides, we have x equals negative 18. So let me go back here. If I put negative 18 here, negative 18 plus 50 is a positive number. So again, that solution checks and I'm okay. So let's look at another equation. We have 6 to the natural log, or 6 times natural log of 2x equals 30. So with this problem, the base for natural log is e. So this becomes, well, first of all, we have to get the natural log on one side. So let us divide both sides by 6. So we have natural log 2x equals 5. Then we can apply base e to both sides. So e and natural log, that cancels. So we have 2x equals e to the 5th, or x is e to the 5th divided by 2. Now that is an exact answer. But if they want a decimal approximation, you can give them one. It's 74.21. And you need to make sure that you read to see how many decimal places they may want you to round to. But needless to say, 74.21, when I put it back here and I multiply by 2, I have a positive number. So yes, that solution checks. Now this one's a little different. I had in the other problems just one log expression. Here I have two. But we can go back to properties that we had to condense logarithmic expressions, and we can condense this. Remember, when you have the same base on both and that you are adding these two, it can condense as multiplication. So this becomes log base 6 of x plus 3 times log base 6 of x plus 4 equals 1. And then I can apply base 6 to both sides. So log base 6 of x plus 3 times x plus 4 equals 6 to the first power. So I have x plus 3 times x plus 4 equals 6. If I multiply out here, I have x squared plus 7x plus 12. Go ahead and bring that 6 over, equals 0. So I have x squared plus 7x plus 6 equals 0. And I can factor this. It factors to x plus 6 times x plus 1. So x is either going to be negative 6 or x is going to be negative 1. So let's check our solutions. Negative 6. If I put negative 6 here, negative 6 plus 3 gives me a negative number back. So that's not a solution. Let's check negative 1. Negative 1 plus 3 is positive. Negative 1 plus 4 is positive. So this answer checks. So now you can see it's very important that you check your solutions. Another strategy we're going to use to solve logarithmic equations is the one-to-one property. So if you have log base b of m equals log base b of n, then m has to equal n. Let's look at an example. Log of 5x plus 1 equals log of 2x plus 3 plus log 2. Well, notice that with this property, you have a single log on both sides. And that's okay. We can get there. We can have log of 5x plus 1 equals. Now here, we can condense this down because this is an addition. It goes together as multiplication. This becomes log of 2 times 2x plus 3. So now we do have a single log on both sides. Log of 5x plus 1 equals log of 2 times 2x plus 3. Then that means that 5x plus 1 is going to be 2 times 2x plus 3. And I'm going to go ahead and write that as 4x plus 6. And I want to solve. So let me subtract 4x from both sides. I'm going to have x plus 1 equals 6. And if I subtract 1, x is going to be 5. So let's see if this is a solution. If I go back to this log, 5 times 5 plus 1 is positive. 5 times 2 plus 3 is positive. So yes, that solution checks. Let's look at another one that we're going to use the one-to-one property with. So here we have natural log x minus 5 minus natural log x plus 4 equals natural log x minus 1 minus natural log x plus 2. Well, again, we need a single natural log on both sides, and we can do that. We have a difference, and a difference will go together as a quotient on both sides. So we have natural log of x minus 5 over x plus 4 equals natural log of x minus 1 over x plus 2. Then we can set these arguments equal to each other. X minus 5 over x plus 4 equals x minus 1 over x plus 2. And we can solve this. We can cross multiply to get x plus 2 times x minus 5 equals x minus 1 times x plus 4. If I use FOIL on both sides, on this left-hand side, I get x squared minus 3x minus 10. On this right-hand side, I get x squared plus 3x minus 4. If I subtract x squared from both sides, it goes away. If I subtract 3x from both sides, I have negative 6x. And if I add 10 to both sides, I have equals 6. So x is a negative 1. And let's see what that produces for us. If I put negative 1 here, negative 1 minus 5 gives me a negative. So that is not a solution. So for this problem, we have no solution. Some books will say that the solution is the empty set. Okay, but that means no solution. So remember that Dr. LB is always in. Please come back for more math help.